properties of logs. I think you know all these things. Just a slight review of them. Do you remember what logarithm stands for, the word? Very good, logical arithmetic. If you are just logical about things, arithmetic, then you can usually get your way through the log laws. Do you have to know every single one? The main ones are the, well, I'll show you for calculus the main ones as we get there. But the log of a product is the sum of the logs if they have the same base. The log of a quotient is the difference of logs if they have the same base. Raising the expression to an exponent is the same as multiplying the logs. And those are all the basic ones that you remember. One thing you might not remember is on the left, those are known as a single logarithm. So when they ask you to write a single logarithm, you can use the word log once. I call the right side an expansion, expanded form. I don't know if you remember that or not when the directions get here. Expanded form. That means everything is knocked down. Notice there aren't any exponents in the expanded form. Everything is basically down to the bare log of the base in the expression. Okay? That's expanded form. How many logs could you have? Well, as many as you have terms, I guess. You can have as many as you want. So, but again, they have to have the same base. What do you do with exponents when you multiply them and they have the same base? What do you do with them? If you multiply exponents with the same base, let's say you have a to the u times a to the w. What do you do with the exponents? You add them. That's why you add these. Logarithms, remember, are related to exponents. They follow the same rules. When you divide with, the same base, what do you do with the exponents? You subtract. That's why you subtract logarithms. And when you raise something to a power, a, u to the c, what do you do with the exponents when you raise it to a power? You multiply them. That's why you multiply, in this case, c times the log. The logarithms are the exponents that generate the problems. So, hopefully we'll get through this. Pretty good shape. This is the first book I recall seeing where there are actual warning signs. Don't confuse this. That is not the sum of a log. You can't distribute a log through a parentheses. The only thing you can distribute is multiplication. You can't distribute, a square root. People still do that. You can't do that either. You can't distribute a squared. U plus W. In fact, some people still make this mistake in this class. You can't do that. Logarithms are a higher order function. You can't distribute higher order functions across addition. Okay, you can only do that with multiplication. It's not a very high order thing. So there's some actually warning signs in there about distribution or, making mistakes. You can't distribute things like that. Signs are also higher order. You can't distribute sine of u plus sine of w. Okay? Any higher order functions you can't distribute. Absolute value you can't distribute. So, anyway, there's log of a quotient. This is a common one also. People get mixed up and confused by that. All right, so don't fall into those traps. Expressed in terms of logarithms, x, y, and z. We'll do the bottom two. How's that? Okay, we'll just do two of them. How do you write the index of a root as a fraction? Yeah, 1/5. So that's a very calculus thing to do. Let's write it as 1/5. And what do you do with the 1/5? Just drop it out in front. Okay? That's not too difficult. Log base 3 of y. I'm going to change this one just for fun. I'm going to change it just for fun. I like to have fun. There. I'm going to change it like that. The log of x base 3 of x squared y to the 5th z squared. It usually comes up somewhere in a test or in a homework. If it's in the denominator, it has a negative exponent because of logarithms. Or you can think of it as grouping with it. But anyway, log base 3 of x squared minus the entire denominator, y to the 5th z squared. Okay? You can write it as the entire denominator. You're subtracting it. Okay? And now you can break this up into a, oh, that 5 doesn't go down there. Y to the 5th z squared. So that doesn't go, I mean, that's the first step. Does everybody write this step? No, but the common mistake is they forget the subtraction sign between the y and the z. The 2 obviously goes down. 2 log base 3 of x minus 5 log base 3 of y. And z, since it's in the denominator, also gets a minus. Minus 2 log base 3 of z. How many people put like lines to their z's? I realize it seems kind of random. That's a good habit to get into, especially when you get to calculus. To put the lines to the z's. Saves a lot of time and trouble. That one's just applying a couple of the log laws, the exponent, the multiplication, and the quotient. Okay? So that's like a good one. Oh, actually, this z is in the denominator, isn't it? And you're subtracting the whole thing. You're subtracting the entire product. You can look at it this way. You're subtracting the entire product. And then you distribute the negative sign to the log. Okay? 2 log base 3 of x minus 5 log base 3 of y minus 2 log base 3 of z. And they all have to have the same bases. Okay? Fantastic. Oh, somebody's sneaking up behind me. All right. Ooh, that looks like fun. You want to do that one or skip it? We just didn't like it, so I think we're in good shape, aren't we? We'll come back to that in about 5 minutes. Here we go. We'll do this one. And then we'll be ready for a brain break, possibly. Natural log of x, the cube root of y to the 4th, z to the 5th. Give this one a go using logarithms. Should be in pretty good shape. And I'll give it a go as well. Does anybody like to organize things before they just like get started? Does anybody take an organizational step? I do too. Natural log of x, y to the 4/3 over z to the 5/3. I'd probably do something like that to get everything in terms of one fraction and one radical. As the cube root and the cube root. So far, so good? Oh, now it's just a matter of personal preference, how you want to look at it. The natural log of x plus the natural log of y minus the natural log of z. Look good? And then drop everything out in front. I think you're done, right? All right. That's a pretty easy section today. If I wasn't mic'd up, I'd do something else. All right. Yeah, logs are easy. Questions? I want like something really tough. You think those are tough?
No.
I don't think so either. I don't know. Let's try this one. Ah, that's not even nothing to try. Log base 4 of 7xy, isn't it? You just put them together like that? I mean, just put them together as a single log. You use the word log once. That doesn't seem very challenging or very difficult. We might get the whole section done today. That'd be all right with me. Oh, now this looks like fun. Let's do this one, then we'll take a brain break.
Fantastic.
It is. I know. All right, a single logarithm. Haha. Oh, it doesn't look that hard. Are people trying to do it like one answer, like one step, one answer, or do you like taking multiple steps? Two steps? 2 steps it is. I'm going to do more than 2 steps. First thing I would do is write the problem down like this. Now I get rid of the parentheses. Oh, that would make a fort. Let's see, y to the 6th, z x squared. The second term, does that go into the numerator or denominator, the y cubed? Denominator, because you are subtracting. And this term, does it numerator or denominator? Numerator. That equals finally log 7 log base 10 of y to the 4th. Is that right? Excellent. That was fun, don't you think? Yeah. Log base 10 of y to the 4th. Sound good? Is it time to try this next one? Where'd it go? Oh, I just found this at lunch. This one is called Twisted. Are you ready for a brain break? This one you do by yourself. All right. In this activity, you will stand up. Put your hands out in front of you and clap and miss. And then rolling your thumbs down, you connect your hands like this, and then you bring it all the way through like this. Okay? And we're on step number 5. It says, roll your shoulders and stretch your back and your neck. See, I'm not tense. Are you tense? Okay. Then it says, then put your right leg over your left. Like a little pretzel. And then roll your neck clockwise. Be careful not to fall. Why that is there, I do not know. Okay. Now, switch your legs and put your left leg over your right. And roll your neck counterclockwise. The other way, Chase. There you go.
I'm not going.
Now,
This way. That's kind of hot.
Yeah, I know.
okay. Now, spell your name quietly backwards. Your first name. You have to do more than E. You have to do the whole thing.
Oh wait, are we supposed to be rotating?
Yeah, you're still supposed to be rotating.
Oh wait, which way?
Yeah. All right. See, some people are following. Now, say your last name backwards. Whose? Oh, I know, but now she has to say her last name backwards. Yeah, you say it. Yeah. Say it backwards.
Yeah, I'm dizzy.
Yeah. Spell your first spell your first name backwards and say your last name backwards.
Say it backwards?
Yeah.
Not spell it?
Right.
Oh, that would be right. Mine would be riprap.
There you go. All right. Who had the easiest name to say backwards? Jilly? Oh yeah, it's the same, isn't it? Yeah. Nice. All right, have a seat, and we'll, I don't know, do some more of this stuff. You had two easy ones. All right, now we're going to solve the equation. In the homework that we answered before, we did take the natural log of both sides. And in this case, once you get the log of the same base, you can drop the logs of both sides if you want to. First of all, we have to get a single logarithm on both sides before we do anything. So, I don't know, apply log law. Log base 4 of 3x plus 2. And what we're going to do with the 5 and the 3, multiply them. And now you have the log base 4 on both sides. It's kind of like when you had 4 to the 3x plus 2 equals 4 to the 15. I know it's not exactly the way it's written, but you can now drop the bases. That's what you're doing when you do the logs, you're dropping the bases. So you can drop the bases. 3x plus 2 equals 15. And 3x equals 13. X equals 13 thirds. Anybody else get 13 thirds?
Yeah.
And what's the one thing you have to be sure of when you're solving for logarithms? Actually, to make sure that this stays positive. Okay? That has to stay positive. Right? So everything bigger than negative 2/3 would work, and obviously 13 thirds is. Good. Give this one a go. It's got 3 different things in it, so that'd be pretty good. It's, oops. I didn't want to do that. Yeah, give this one a go. It's got a cute little thing there at the end. Solve the equation. Yeah, sure. Look at it. Look at that. Log base 4 of 3 up there, stuck up there like an ornament. I like that. Oh, they're not all the same base, though. Interesting.
That's a problem.
You can. Spartans are retreat, no surrender. Let's go, buck up. You know, you want to walk by and touch the juggernaut tonight? You'll learn to do this problem. You can't get your picture taken next to it.
What the heck? That was the same have a base.
It does have a base. What's the base when it's not listed? 10.
I know.
Exactly. Luke can, well, he can't drive the juggernaut, but he can actually ride on it if he wanted to. Log base 2 of x plus 3. Four log to the log 4 3.
It doesn't have that first log plus x.
Oh, there we go.
That was just,
Oh, you guys, you could have done that. Oh, what about the 9? How can you rewrite that? 3 squared, okay. Plus 4 log base 4 of 3. Now, you can either break out the calculator or you can just start working things out.
Can you get the log base?
The log base 2, sure. X plus 3 minus log base 2 of x minus 3. You can move things around. Equals, what is log base 3 of 3 squared going to equal?
2.
That's going to equal 2. And 4 log base 4 of 3. I don't either. Well, I can find out, though. I don't know if it's 3 or not. I'm going to just... How do you know? Well, yeah, but I don't know all the properties. Not all the time. Hey, here it is. I'm just going to punch it out. Anybody, did anybody punch it out? Oh, the calculator. No, I'm just going to go to the home screen and calculate it. Clear, view. You don't have to. 4 caret, parentheses. How do you type out log base 4 of 3 again?
Oh, you're just doing that.
Yeah, log of 3 over log of 4. There, it does equal 3. Okay? So 3. Are we getting any closer?
Maybe.
Log base 2 of the quotient, x plus 3, divided by x minus 3, equals 5. Whoa, it's a logarithmic equation. How do we solve it now? Change it to what? Exponential. We're getting closer. Let's see, 2 to the 5th, 16 is 4, 32, right? 32x, 32 times 9 is 96.
Yep.
Ooh. So 31x equals 99? 99 31st? Does that work?
Sure.
I don't know. 99 31st? Oh, it makes it positive, so sure. I like that. That was fun.
And that
Are there any like that in your textbook to do?
was number.
That was number 34, so yeah, 33.
Excellent. No, it's time to graph this one out.
No, we don't.
What is, oh, I'm going to get the 5 for 10 tomorrow. Remember, I need activities for tomorrow in case the juggernaut blows the gasket tonight. You will be. All right, how do you graph out log? Quiet, please. Log base 3 of x. How do you graph that out?
I am not being known.
Shh. Log base 3 of x, what do you do? Yeah, you can pay a calculator. What's it going to look like?
Line.
Well, this would look like an exponential function, right? What would the log function look like? This way. Good. Yes?
What is the juggernaut? Is it the bus that the...
It's the
I'll explain after I'm off the mic. 1/3. What's the 1/3 going to do?
Wait, why is it 2?
It's going to affect the y. Is it going to vertically stretch it or compress it? It should compress it, I would think. And as we know, we talked about how to graph those things on the calculator. So I'm just going to put in 1 divided by 3. Now how do we do log base 3 of x on here again? Log of x divided by the log of 3. Okay. Zoom 6. Now there is the 1/3 part, second, it's not a second, just y equals. And here's the part without it. So I think it is a compression because the log of x divided by the log of 3 would rise up just a little bit quicker than, so yeah, so there's a vertical compression. You're actually pushing it towards the graph, or towards the x-axis by a factor of 3.
I thought the fractions made it wider. Is that
The fractions made it wider. Right, because you're compressing, you're pushing down on the graph.
oh,
So if you're pushing down on this graph, it's not going to make it wider, it's going to make it closer to the x-axis. So it's a compression. Okay? All right. Sketch the graph. That doesn't look like fun. Cube root. How can that? Oh, I know why it's on there. See if you can use your calculator. Well, I think we are all pretty skilled in that regard. You'll be surprised how many people don't know how to use a calculator when you go off somewhere to school. Math 4x divided by log of 2. Graph it out. I think it'd be a very narrow graph again. Yeah, it would.
that looks like
Yeah, it sort of does. You could change your window if you wanted to investigate it further, but there is a vertical asymptote right here. Okay, there's a vertical asymptote there. I mean, don't forget that. It's crossing at 1, 0. I mean, we know that to be true. So, yeah, those things are things you put on your graph. Interesting. We might finish. Maybe we, oh, no, we won't.
So, yeah, I think this is a good place to stop.
Oh, no, look at all these words.
No.
I like that. How is, what problem number is this? I gotta have time to get a grade tomorrow.
54.
So I'll go 1 through 53 odd. On what page? Page what? 326? 336? All right, ready? 353?
No, I'm asking why.
336.
Oh, somebody said we're stopping here.
Questions 1 through 53.
Well, you can do those. If not, we'll go over tomorrow. Nice.